Hi, this is Vitek from NVtronics. This video is intended for members of my forum involved in RCO research and work. Okay guys, this is the first setup. I haven't changed anything. There is still choke. I replaced capacitor. I had two section capacitor before, and I have far better tuning with this guy, and the wires going to the center tap are old test leads, but this is the new one I recently modified, and as you can see I put two vertical members. The copper is 1.5 millimeter in diameter, and I just changed the transistors. I had those before 2SD1314, and I replaced with Toshiba 2SC5200. They are also NPN, pretty hard to kill. They are rated at 230 volts and 15 amps. They're supposed to be good up to 30 megahertz, though, so they should be better than those I had before. And I also replaced capacitor, and I am covering the whole usable range right now, and I put the boost converter. I'm feeding from 12 volt from power supply. The current draw is slightly over 300 milliamps, and boost converter it's stepping up to 25 volts. I want to show you the wave right now. That's how it looks like, and those are the oscillations which are puzzling me a little bit. The capacitor is nearly closed right now. It's at its maximum capacitance. Now I'll be slightly opening, decreasing the capacitance, and you don't need to see that, take my word for it, but I will show you what's going on the scope while I'm increasing the capacitance. The current draw right now is around 350 milliamps. And now dropped again to 320, 300. It stays at 300. And as you can see, the amplitude it's going up right now. The current is starting to increase. I am at 320, so less than while I have those oscillation before, but the amplitude is higher. 330, 350. Now it's going up steep. Now I am at 400 milliamps, 470, 500, and I am backing capacitor right now to the point where we started. Okay, so we are back at those. I'm gonna put the loop with the LED. it's about 10 centimeter from the TX loop. So I'll be doing the same thing, and I'll be showing you the scope and the LED. So right now, okay, we are doing the same what we did before. So I'm slightly going up, and the current is starting to drop. Now it's getting higher. That's one of those peaks. Now if I can just stabilize the, okay, and that's the wave I have okay, that's the wave I have right now. And the current draw right now it's 320 approximately. Okay, I'll keep going up. Now the current drops. I'm close to 300, but from 320 to 300 I didn't notice any changes in LED brightness. Now I am at 320, but the amplitude, I have a half a volt per division, so that's 2 volts right now. So that's about slightly over a volt and a half from the from the beginning when it comes to the amplitude. And okay, I'm still increasing. I am at 350. And that's pretty much the maximum amplitude. I am right now at 460, almost 460 milliamps, and that's the highest amplitude I can get. But the LED is not the brightest anymore. It's actually dimmer. I can back a little bit. And that's roughly the brightest spot. And right now the current is just hovering over 300. And the amplitude, it's about more than half a volt less right now, but the LED is the brightest. And I made another loop with the incandescent grain of wheat bulb. Okay, I'm placing about half a distance between the one with the LED, so it's about 5 centimeters, and you can see the bulb is lit. And I will go back to those oscillations. You see, like, the LED is getting dimmer, but the current draw is getting higher. I'm at 350 almost, and the amplitude is just around 1 volt right now. And now you see the wave changes. And now is the moment when the LED gets brighter again, and I see those oscillations. I will change the time. Okay. I think that's the best I can do. So that's what I was referring to when I meant the oscillations. And it's again kind of a sweet spot, because the current, it's 330, just slightly higher, lower capacitance was at 350. So there are couple sweet spots when comes to tuning. I am sensing with that 2-turn coil plug into a scope. So anyway, it's pretty much old. That's the choke which I had before. It's a ferrite choke, and there are 2 windings, 10 turns, and it was connected with the power supply coming to the circuit before. So one side was on the positive rail, one was on a negative rail, on a common core. And as far as the temperature goes, it's pretty much (26, 27, 26). So it's not much in terms of heat coming out. The heat sinks are not really that big. So anyway, that's, I think I show you what I meant to show you. So anyway, see you back at the forum. Thank you for watching.